This Cisco Networking Academy work. This is Chapter 3, VLANs, and we got into a lot of the details of VLANs, and we'd like to get started on that. A little bit of review on our notes. Start off with, we have two switches, and those two switches are connected. Don't worry about the routing device here yet. We'll talk about that later. Then we also have here my representation of access point, and that access point's connected to a switch. And then we create some VLANs. For example, a VLAN 20, and we said that was on some network, and we used a .20 in here. There was no real rhyme or reason that that would have to be that. We just picked that the easier way to remember which network is which. And then we did the following. We also did a blue one. We call this VLAN 10. We have some devices connected on the blue. And then we also did a green one here. All those devices are connected to this same switch right here. Connected to the same switch. But none of these can talk to each other. They couldn't unless, later on we'll talk about it, we could run a trunk up to a routing device that can route between networks. Now if you notice, also over here we created a management VLAN. We actually VLAN 99, we put a PC there, so that port wouldn't communicate with any of the other ports on the device. And then you will notice that we also put a VLAN 20 up here, and the blue VLAN here, and then also the green VLAN 30 there. Now, in order for a frame to move through this switch here up to this switch up here, if the packets were coming from the blue VLAN, at this point here they'd be tagged on the trunk so that when they hit this switch they would be in the blue VLAN. So the trunk allows us to tag traffic between VLANs. The information, for example, the information on the PCs really don't realize they're on any particular VLAN. They wouldn't be able to realize. They just don't, because nothing gets tagged until it moves through a trunk internally. And it wouldn't have to be. In here, these are all kept separate. They can't communicate to each other. The same thing up here. These ports can't communicate each other until later on, and it isn't until Chapter 5 that we talk about inter VLAN routing, where we send it up to a router makes the decision, and then traffic can return to the correct VLAN. Same thing's true in an access point. An access point can also have, based on the SSID, different VLANs. And so a wireless device on the red VLAN here, and then the trunk would carry that traffic with the tag, and on the red VLAN, for example, it's a number with the number 20 in it somewheres, and we tagged as it moves into the switch. Alright, one other thing we mentioned, native VLAN. Years ago, when we would have a switch, we might have an extra switch that is not VLAN capable, so you could connect that via native VLAN and no tagging would be transferred with that. We talk a little more about the native VLAN later on. One last item, if you have a port, let's just say one of the red ports, and we connect a switch onto that red port, and these were access ports, so there was no trunking, then everything on this switch can be on that same VLAN. So everything would have that same IP, 172.25, in this case 20.0, and the mask there is 255, 255, 255, and /24. They could all communicate with the switch and everything in the red VLAN. Alright, we also talked about briefly how a VPN connecting two networks using maybe IPsec. A student made a comparison to alright, so we could connect through here on a virtual VPN, virtual private network. And we talked a little bit about that. It's referred to like a tunnel going through the internet. The packets are still packet switched inside the internet. You know, you don't know what route they're going to take. But what you can do is you can encrypt it on each end so that it only sees the destination IP, goes in, they get routed through, and then they come back over here and we decrypt it. And from the point of view of your two networks, it looks just like a LAN. It really does. And there's a couple different ways of doing that. Alright, well, that's it for our information today.